Okay, today we're going to go through section 3.2 called combining forces. So in this section, there's two important topics that we're going to go through. The first one is being able to draw a tree diagram. So drawing a tree diagram. All right, so here's an example. So suppose that a couple is planning to have 3 children. And they wanted to draw a tree diagram. And determine the total number of outcomes and the list of the sample space. Okay, all right, so what you do is you're gonna need a couple of highlighters. As you can see, I'm gonna use orange and yellow. All right, so you start with your parents. They're the parents. Right there. And they want to have 3 kids. So what's going to happen with the firstborn, right? So the firstborn, you draw your little branch. So the firstborn can either be male or female. That's the firstborn. That's the first layer. The secondborn, right? We're going to branch off for the male, branch off for the female. So the secondborn can be, if the first one is male, it can be, the second one can be male or female. And if the firstborn is female, you can have male or female. So that's the secondborn. Thirdborn, you're going to draw branches off each of the secondborn. Right. I don't know why I put A, but we can branch off of all of those and put male and female. And so how many total outcomes are we going to have? All right, so here's what you do. So I'm going to write down my sample space. I'm going to do my little braces, and I start. If my firstborn is male, and follow it. Second one's male. Third is male. There's my first sample space. Male, male, male. So that means all of them are males. You can have male, male, female. You can have male, the first one's male, second one's female, and then the third is male. So you can have MFM. And you can have MFF. Male, female, female. Now, starting with the firstborn being female, you can have female, then male, then male. You can have female, male, female. Or you can have female, female, male. Or you can have female, female, female. And that are my sample spaces. So how many do I have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 total outcomes. And so we introduce you to a principle based off of the tree diagram, which we're gonna call it the fundamental counting principle. So the fundamental counting principle says that in a sequence of n procedures, if the first can occur in k sub 1, it's a k with a 1 like subscript ways, the second in k sub 2 ways, and the third in k sub 3 ways, and so on. Dot, dot, dot. The total number of ways the sequence of procedures can occur is k sub 1 times k sub 2 times k sub 3 times 4 times dot, 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 all the way to k sub n. You're multiplying all the k subs. And that'll give you the total number of outcomes. But a little note here, this procedure can only occur when the occurrences of all events have no effect on each other. So that means one event does not affect the outcome of the other. You have different categories. You can multiply them, and that'll tell you the number of outcomes. So like our example with our children, right? You had firstborn, secondborn, thirdborn. The outcome of the second one does not depend on the first one, and neither does the third one have any effect on the other. These have no effect on third. So they're all different. So firstborn, how many choices do I have for the firstborn? How many different genders do I have? I have 2 of them. There's 2 genders. Secondborn also has 2 genders. And the third has 2. Right? So you multiply them. 2 times 2 times 2 gives us 8 total outcomes. If I didn't have to list them, I knew if I did ask you to figure out how many outcomes you're going to have total, you can just multiply the numbers and it will give you your total number. If you had to list them, well, then you have to draw the little tree diagram to know what they are. Right, so we'll do another example. Do another example. This time we won't actually do the tree diagram. Let's just figure out how many total outcomes there are for this example. So suppose and be real nice. I'll take y'all out to eat. We'll go to a buffet. We'll get to a buffet. We shouldn't go. It's still dangerous. But let's just say that everything's all back to normal. No more COVID, no more war. Back to normal. And Mr. Guerra's liberal arts class. Goes to a buffet. Goes to eat at a buffet restaurant. And so in the restaurant, you can have an appetizer, a drink, a main course, and a dessert. An appetizer, a drink, main course, and dessert. I think there's 2 S's. Sorry, 2 S's. Dessert. So for appetizers, what are our choices? What are our choices for appetizers? All right, so we can get salad, soup, chips, salsa. Ooh, fried pickles. We had fried pickles this weekend. Delicious. Mayonnaise. Those are appetizers. And for our drinks, of course, they will be non-alcoholic, I assume. All right, we could make it. When you guys can, because y'all are too young to be drinking. All right, so we'll put water, tea, soft drinks, lemonade, And all right, we'll put adult beverages. And then for main course, let's see, what can we do for our main course? We could do steak, hamburgers. My pen's running out. Steak, hamburgers. I haven't been to a buffet in a long time. Tacos, enchiladas, grilled chicken, pizza, fish, shrimp. And then for our dessert, and for dessert, what can we get for dessert? For dessert, we can get what I have here: ice cream, cake, ice cream, cake, Jello. Jello. I haven't had Jello in a long time. Lemon tarts, pie, cookies, brownies, and gingerbread. So you have different categories, right? There are independent. You have appetizers that by themselves, drinks, main course, desserts. Okay. So how many choices do I have for my appetizers? I have 1, 2, 3. I have 5 choices. For the drinks, I have 1, 2, 3, 4, 5. 5 choices. For the main course, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 choices. And dessert, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 choices. So my fundamental counting principle says that they are all independent. I can simply multiply all of those number of choices, and that'll tell me the number of total different outcomes or different combinations of appetizers, drinks, main courses, and desserts I can create. I'm going to multiply 5 times 5 times 8 times 8. And what do you know? I get a total of 1,600 different choices. So I'm multiplying 5 times 5 times 8 times 8. Gives me 1,600 different choices or outcomes. Simple. You just multiply. Multiply the total amount of choices per item, and there you are. Using your fundamental counting principle, multiply them, that'll tell you your count. If you want to draw a tree diagram, it'll be messy. I can show you how I started it off. And it doesn't have to be in any specific order. You can choose wherever you want to start. So let's say that here's my little person. I want to go ahead and do the appetizers first. So I listed the appetizers: salad, soup, chip, salsa, fried pickles, onion rings, and then I do the drinks next. Spread it out. I'm going to draw 5 little stems for each of those 5. So water, tea, sodas, lemonade, adult, same thing. And you keep branching it off. Branch it, branch, branch. And you can see that it does get it complicated when you have a whole bunch of nested items. But that's the procedure that you would do to create a tree diagram. So let's do one that's doable. We can do a tree diagram that's doable. And we can use our fundamental accounting principles. So I'm gonna have to do this one sideways. So suppose that you are going to buy furniture for your apartment. With the money that you got from the IRS. I ain't getting any money, that's for sure. I'm paying. And you're looking at two. We're looking to buy a couch. It comes in leather or micro soft Microsoft suede, I think. Microsoft suede. And colors to choose is 10 gray, red, or black. Those are the colors that you have to choose from. All right. Draw a tree diagram. All right. So let's draw a picture of you. Again, I'm not a good artist, but I'm pretty sure you are a good artist. Look, he has a tail. He doesn't seem happy, really. He's very happy. Right, there you are. All right, and you're gonna buy a couch. All right, so it comes in two types of material, either leather. I'm gonna put a little legend. I'm gonna let L equal leather. L is equal to leather. And I'll put MS to be your Microsoft Suite. There's one legend, right? So I'm gonna put L and MS. And I'm gonna do a legend for the colors. Here are the colors. I'm gonna use T for tan, and G for gray, R for red, and B for black. So I have to draw 4 little sticks for each of the types of material. So colors is tan, gray, red, black. Tan, gray, red, black. And now I wanna okay, so now let's list the outcomes. I should have 8. Let's see. Let's see if there's 8. So if I get my little highlighter, I have LT, LG, LR, LB. Leather tan, leather gray, leather red, leather black. Micro suede tan, micro suede gray, micro suede red, and micro suede. So I should have 1, 2, 3, 4, 5, 6, 8. 8 outcomes. All right, and I think we're done with our lesson.